Hi everyone, in this lecture we are going to talk about creating histograms with NumPy arrays. NumPy can also be used to plot histograms on your data. Histograms allow you to view distributions of your numeric data and are a great tool for analysis. So let's go ahead and let's create our first histogram. I'm going to say np.histogram. And I'm going to pass in 1, 2, 3. And for the bins, which I'm going to explain, I'm going to pass in 0, 1, 2, and 3. So 1, this is going to be 1, 2, 1. This 1, 2, 1, it refers to the data over which the histogram is computed, which is our actual data points, 1, 2, 1. The 0, 1, 2, 3 refers to histogram bins. A histogram displays data. A histogram displays numerical data by grouping data into bins of equal widths. Each bin is plotted as a bar whose height corresponds to how many data points are in that bin. Bins are also called intervals, classes, or buckets. Let's run this. Now this is going to give us an array that says 0 and 2 and 1. 0 says 0 instances in the bin 0. 2 says 2 instances in the bin 1. 1 says 1 instance in the bin 2. What does that mean? It means that there are 0 data points with value 0. As you can see, we don't have any data point with value 0. We just have 1, 2, 1. There are 2 data points with value 1. There are 2 data points. And there is 1 data point with value 2. That's basically what it means. Again, there are 0 data points with value 0. There are 2 data points with value 1. And there is 1 data point with value 2. That is what this 0, 2, 1 means. Now let's create a random normal distribution in NumPy using the np.random.normal function. This is going to be a normal distribution with a mean of 2 and a standard deviation of 0.5. And the resulting array, NumPy array, assigned to data will have 10,000 points. So I'm going to say mu and sigma. Let's set it to 2. This is going to be the mean, and the standard deviation is going to be 0.5. There we go. And then we are going to grab the data variable, and I'm going to say np.random. I want to create random numbers. Normal, random.normal. Let's pass in the mu, which is the mean. Let's pass in the sigma, which is the standard deviation. And let's pass in the number of data points. 10,000. Let's run that. Let's take a look at our data. There we go. So we have an array of 1 dimensions, and there are going to be 10,000s within that array. Now let's create a histogram over this data using np.histogram. And let's provide 50 bins in our histogram. The histogram function, as we have seen before, returns 2 values. The first is going to be n, which gives the occurrences of data that fall within each bin. Again, when we had 0, 2, 1 in the bin 0, we have no data points. In the bin 0, in the bin 1, we have 2 data points. In the bin 2, we have 1 data point. All right. So let's go ahead and let's create this variable, and I'm going to say n, and I'm going to provide bin edges. Is that correct? This is correct. And I'm going to set it equal to np.histogram. Let's provide the data that we have. And how many bins do we want? We want 50 bins. The bin edges here refers to the values on the x-axis of our histogram, which marks the boundaries of each bin. There is a bin edge corresponding to each of the 50 bins in our histogram. Let's run this. And let's take a look at our n. Let's take a look at the ends. So there should be 50 ends, right? Let's run that. If you count them, there are going to be 50 n's, and corresponding to each n, we are going to have the edges for that n, right? So I'm going to say bin underscore edges. Let's run that, and we have 50 edges for that. All right, and keep this in mind that this is going to be like this is drawn based on this data that we have, this 10,000 data that we've had. All right, and let's actually draw a histogram of these 50 bins. Okay, so I'm going to say plt.plot. We know how we can draw that. Now this is going to accept two arguments. The first one is going to be the x-axis. The second one is going to be the y-axis. For the x-axis, we have our bin edges variable, which I'm going to provide an index, which is going to start from 1 and go all the way to whatever. And then for the y-axis, we are going to provide n. Then I'm going to say plt.show. Let's run that. Here is the histogram that we have. Now we plot the bin edges again on the x-axis and the actual histogram n on the y-axis. And the result, as you can see here, is our normal distribution of a mean of 2 and standard deviation of 0.5. That's it for this lecture. See you in the next one.